Welcome back to DellyMaths Concepts. What we're looking at today is a circle theorem question. So I'm just going to quickly go through. So here's a question. It reads, V, X, Y, and Z lie on the circumference of a circle shown below. So we're seeing that. The center O, diameter is VY. UW is a tangent to the circle at V. Angle VXZ is 62. We got that. And angle XVY is 18. We also got those. Now, let's see what the first question says. The first question says, state the theorem that justifies the values of each of the following. All right, so we're just going to state the theorem that justify these values. So angle B is 62. So let's take a look why angle B is 62. So when we look at this, angle B is 62. Let us take a look. When we think of angle B, we are looking at this angle out here. Right? Now, that angle out there is actually corresponding with this angle out here. So when I say corresponding, I'm referring to the fact that they're in the same segment. That's what I meant. So this angle at B is actually in the same segment as the angle 62. As you could see, they are both standing on the same chord here. All right. So B is 62 because of the theorem that says angle in the same segment are equal, right? So it's in the same segment. Let's put it in. So for this, we're looking at the fact that angle in the same segment, and we could just say subtended from the same, so subtended from the endpoints of a chord. Right? So it's basically the fact that you say the angle in the same segment, that's basically it. So I'm just saying it's subtended from the endpoint of a chord. Those angles are equal. So if we have that, then we're good. So that is why this is 62, angle in the same segment. Let's look on angle C. All right, so angle C is at the center. Let's take a look at this. So this angle at the center here was actually subtended from the chord ZV. So you could see that that's the chord that went to the center, and it also went to the circumference. So the theorem states that angle at the center is 2 times the angle at the circumference, all right, providing that they're coming from the endpoints of this same chord. So as you could see, that 62 times 2 would have given you the 124 degrees. So we could say angle at the center is twice the angle at the circumference. And that's basically what we're saying right there, right? Providing that they're coming from that same chord. All right, let us look at angle OVW. It's 90. All right, so we're looking at this. OVW. Definitely it's 90 degrees. So that's where a radius meets a tangent. So radius does meet a tangent at 90 degrees, and that is why, that's our justification for that. So the theorem states that radius meets tangent at 90 degrees. So that's the theorem that we're using right there. All right. So this one says find the values of A, D, and E. Show all working where appropriate. All right. So where it is appropriate, we're going to have to do a little calculations. All right. Let's see what we have. Angle at A. Let us see what angle A is. All right. So, okay. So we're looking at angle A, which is this angle right here. Now, if I should highlight a particular triangle, because there are a number of ways to get to the answers, but I'm going to get to it using this. And then I'm going to highlight the tangent line here. Now, there is a theorem here that says that an angle that is formed between a chord and a tangent, which is A, it's going to equal to the angle, we're looking at this triangle now, that is in the other segment. So it is called the alternate segment theorem. All right. So basically A is equal to 62 degrees, and there's no calculation for that, right? They never suggested to give a reason for it. So I'm just going to put the answer, and it is 62. So it's the angle that is formed between a chord and a tangent. It's going to equal to the angle in the alternate segment. And you could see that this tangent, this chord here, split the circle into one segment here, and then the other segment would have been on this side. So this angle was caught in the bigger segment, all right? So that's the theorem that we would have used to fit that together. So let's put this on. This is a 62. Let's see what other questions. So we have D, angle at D. Now, remember that this was 124. Now, I'm going to highlight this triangle here so that we can focus on the idea. So this is a triangle that's going to help us to find the angle at D right here. Now, bear in mind that the total interior angle of any triangle is 180 degrees, but this is a special triangle from O to Z is the same distance as O to V because they are both radius from that same circle. That means we have an isosceles triangle and the base angles are equal, which means that D is going to be the same value as this as well. So what we're going to do here is that we're going to take 124. So we're going to subtract. So we're working on the angle at D here. Okay, guys, we're working on the angle at D. It's going to equal to 124 from 180, and then we're going to divide that into two equal pieces, right? So if I have 124 and I subtract that, I'm going to be left with, let's say, what, about 56, right? So that's about 56 right there. And then 56 divided by 2, we're going to have about 28 degrees. So this right here is 28 degrees right there. So we're looking at 28 degrees right there, as you could see, for D, 28 degrees. So D is actually 28 degrees. All right, let's continue going. We want to find E. All right, now we want to find E. So what I'm going to do again is I'm going to focus on a particular triangle here. So let me just clear off some unnecessary things so we could zoom in on the triangle that we want. Take a look at this. I'm going to focus on this triangle where we were told earlier on that Vy is the diameter to the circle. So look at this triangle that says VYZ. Now, we note one of the theorems suggests that angle that is formed in a semicircle is 90. So this is actually 90 degrees. That angle right there is all of 90 degrees. And that's one of our tickets out. We just found out that this is 28. Now, this angle here is actually in the same segment as 18. So take a look at 18. This would have been the chord for them right here. So this is also 18, right? So if we look at it from that angle, then 90 degrees take away 18 plus 28 would have given us E. So we can find E easily by saying 90 degrees was there, and then I'm going to sum the 28 plus that 18. So I'm going to take that. So it's going to be 90 minus 46. And that's going to give us about 44. So right here is 44 degrees. So there it is, putting all the theories together and simply working out our way. So we're done.